This is another video about finding volume. So this time we're going to find some volume of different composite figures and different shapes that we have talked about before. Number one, we want to find the volume of a frustrum. Remember that a frustrum is just a cone that had part of it chopped off. So if we draw in the rest of our triangle up here for our cone, we can use similar figures to find some of the missing dimensions. So I want to find this part over here, x. So if I set up similar triangles, I would have 4 over 12 equals x over x plus 10. So when we cross multiply, we get 4x plus 40 is equal to 12x. We get 40 equals 8x, which means that x is 5. So if we know this length is 5, we can do Pythagorean theorem to find the height of the smaller triangle and of the larger triangle. So in the smaller triangle, we have 5 squared equals 4 squared y squared. 25 equals 16 plus y squared. 9 equals y squared, so y is 9. Or, sorry, y is 3. Then if we do the whole length here of the bigger triangle, we have 12, and we know that this side is 15. We have 15 squared equals 12 squared plus x squared, so we get 225 is equal to 144 plus x squared. 81, or we'll call it z squared. 81 equals z squared, so z is 9. So if this whole length is 9, that means the height down here would be 6. So now we can find our volume by doing the volume of the big cone and then taking out the volume of the small part of the cone that was chopped off. So remember, the volume of the cone is 1/3 base area times height. So we have 1/3 times pi 12 squared for our bigger base times the height of 9 minus 1/3 pi 4 squared for the smaller base times the height of 3. So that gets us 432 pi minus 16 pi, which is going to give us a total volume of 416 pi centimeters cubed. Remember that volume is always cubed units. In number 2, we look to have a half of a cylinder that has 2 smaller half cylinders cut out of it. So from the top view, we see that the diameter of the large cylinder is 20, which means that the radius would be 10, which is also the diameter of the smaller circle, which would have a radius then of 5. So if we are trying to find our area, usually the area of a cylinder is base times height, but we have half of one, so we're going to do half of that. So half times the base area, which of the bigger cylinder would be pi 10 squared times the height of 18. Minus, there are 2 half smaller cylinders cut out. So we're going to do 2 times 1/2 pi 5 squared times 18. So when we multiply there, we get 900 pi minus 450 pi, which will get us 450 pi millimeters squared for our, or millimeters cubed for our total value. In number 3, we have what looks like a tall rectangle prism with a rectangle pyramid on the top. So in this case, we have our prism that has a height of 12 and a total height of 21. So when we do 12 minus 21, we get a height in the pyramid is going to be 9. So we have all the information we need to do our area. So for the prism, it is the base area, so 3 times 5 for the rectangle, times the height of 12, plus for a pyramid, it is 1/3 the base area, which is 3 times 5 again, times the height of 9. So when we multiply, we get 180 plus 45, which is equal to 225 centimeters cubed. In number 4, we have a cylinder that is cut on a slant. So what we're actually going to do is we're going to split this into two. So we know that the whole height is 20, which means the height of this half cylinder is going to be 6 because the height to the flat part of the cut is 14. So 20 minus 14 got us 6. We know that the diameter of it is 8, so it has a radius of 4. So if we do the regular cylinder on the bottom, it's base area pi 4 squared times the height. Then we have half of a cylinder that was cut. So when we do that, we're going to do 1/2 the base area times the height. So in this case, then, we get 224 pi plus 48 pi. When we add those together, we get 272 pi feet cubed. In number 5, we want to find the total volume. So we have 3 shapes here. We have a hemisphere, we have a cylinder, and we have a cone. So we know that if this is the diameter of 16, that the radius is 8. It's also a radius of 8 in our cone. If we do Pythagorean theorem to find the height of the cone, 17 squared equals 8 squared plus x squared. 289 is equal to 64 plus x squared. 225 equals x squared. So x is 15. If we subtract the 15 from the cone and the 8 from the hemisphere away from the 35, the height of the cylinder is 12. So we now have all of our information. So to find the volume of a hemisphere, it is 2/3 pi r cubed. So that's going to be 2/3 pi 8 cubed, which gets us 1,024 over 3 pi, plus the volume of the cylinder, which is the base area times the height, or pi r squared times the height. So we have pi 8 squared times 12, which would get us 768 pi, plus the area of the cone, which is 1/3 the base area pi r squared times the height. So 1/3 pi 8 squared times 15, which is 320 pi. When we add that together, we get 4,288 over 3 pi meters cubed. In number 6, the diameter of a softball is approximately 4 inches. A box holds 3 softballs with the edges of the softball just hitting each side of the box. The box has a square base. So we want to find the total volume of the softballs. So they are a hemisphere, and we have 3 of them. If the diameter is 4, that means that our radius is 2. So we have 4/3 pi times 2 cubed, but there are 3 of them. So when we multiply that, we get 32 pi inches cubed. Then we want to find the volume of the box. So they said that the volume, it fits 3 softballs and it's going side to side in the box. So if the softball is touching and has a diameter of 4 inches, that means the dimensions of the box are 4x4 for the base. And if there are 3 softballs stacked on top of each other, each with a diameter of 4, that means the height is 12. So to find the volume of the box, we would have 4 times 4 times the height of 12, which is 192 pi inches cubed. To find the volume of the empty space, then, we would subtract the volume of the box minus the volume of the softballs. We can put this in our calculator and round to 2 decimal places, so we get 91.47 inches cubed for the empty space. In number 7, the volume of a cylinder is 980 pi miles cubed. If the height of the cylinder is 5 miles, what is the radius? So when we are doing volume, we would have the base area times the height. Well, because it's a circle, the base area is pi r squared times the height of 5. So we have 980 pi equals 5 pi r squared. We can divide both sides by 5 pi, so we get 196 equals r squared, which means the square root gets us r is 14. So our radius is going to be 14 miles. In number 8, a pyramid with a regular octagonal base has a height of 27. A side of the base is 18. Find the volume of the pyramid to the nearest thousandth. So in number 8, we're going to draw our triangle to represent part of the octagon. So if the octagon has a side of 18, when we draw our apothem, that's going to split the side into 9 and 9. In an octagon, when we divide 360 divided by 8 sides divided by 2, we get that top angle is 22.5 degrees. We want our apothem, so we can use trig. The tangent of 22.5 equals the opposite over the adjacent, so 9 over a. The trig and the variable can switch, so 9 over the tangent of 22.5 equals a as our apothem. So to find the volume, it is 1/3 base area times height. Well, the base area is going to be 1/2 times our apothem times our perimeter. If each side is 18 and there are 8 sides, 18 times 8 is going to get us a perimeter of 144, and then times the height of 27. So when we multiply that out, we can stick it all in our calculator, and we get 14,079.694 meters cubed.